Hi, welcome everyone. In today's video, I'm going to talk about GMM models in Stata, and there will be several models, and the narration will be developed from simple models to advanced. So I will be use AB data, which is already available in the Stata library, and this data is about. I will show you the variable names. It's about the employment, wage, capital investment, industrial output, employment rate, wage rate, and then capital this is K for the name is written in here. So I will show you the name. So K is for the log of fixed capital, and N is for log of employment rate, and W is for log of wage rate, and YS is log of industrial output. So I will run the first regression, simple regression, that is showing wage is a function and capital and industrial output is a function, and they are explaining employment. So wage has a negative effect, all others have a positive effect. So I will declare data as a panel data. So if you use XT test 2, it will also tell you how many cross sections are there and if there are any gaps in years and how many average years and what are the minimum years and what are the maximum years. And this is the model that is simple regression. Okay. Now we can use regression with a lag of dependent variable. Mostly people use this lag of dependent variable because of few reasons. First reason is it is because of theory. A second reason is sometimes the dependent variable is so small to change. Its range or its rate of change is so small that it cannot be picked up by other variables. And then what we try to do is we use the past of that variable to explain the present. So this way it will improves the model. So this is the simple regression with lag of dependent variable, and so you can see that the coefficient value is high enough. This is showing that the present values are changing very fast. It changes very much when it depends a lot on the lag. Now we start with the fixed effect model with the lag of dependent variable, and we run it, and it's called fixed effect model. Results are here, and then I will use the random effect model. And you should know that according to the reference that I will show you later on, that if you have a lag of dependent variable in the panel data, it leads to a Nikel bias in the estimates, and the the issue that is created because of Nikel bias is similar to endogeneity. That's why we use similar approach in the panel data. We assume that Nikel bias is similar to endogeneity. So the solution used to solve the Nikel bias is same as the solution that we use to solve endogeneity. So the models that we are discussing here are using the GMM or instrumental variable regressions, which are used with the intentions to control the endogeneity when we use the lag of dependent variable. That's why these models are also called dynamic panel data models, and these models can also be used to solve the endogeneity because of some other variable, but they are specifically discussed when you have a lag of dependent variable. We also call it AR1 equation. So we have done both models. Now I compare the Hausman test, and since the Hausman test is significant, we say the fixed model is better. But you should know that there is chances of endogeneity because of bias, and the output, the note is shown here. So how does the regression solve this problem, assuming that it is endogeneity or Nikel bias, because both have similar consequences? What the regression does, it finds lags from the past of that independent variable which is endogenous and which is also the lag of dependent. So second lag and third lag of the variable will be used as instruments. First we will do the regression of lag of dependent variable with second or third lag and independent variables, and then predict the estimated value. Okay, y hat. So that y hat variable will be used. Y hat variable is the portion of the lag of n, which is because of the independent variables. So, and then we use that instead of lag of n. So we use n hat. estimated employment rate. So we run regression. This is now fixed effect model with USLS, or you will also call it a model which we use instrumental variable regression in a panel data. Now, and we can also do it for random effect, and it is estimated here. You can see most of the variables are significant. And then we compare instrumental FE with instrumental RE. So it says that fixed effect is better. So what we'll do, we'll compare instrumental fixed effect with non-instrumental fixed effect. If it is insignificant, it means that the use of instrument has not created any change in the estimates. What does it mean? That there was no endogeneity. So since it is significant, it is showing that the instrumental fixed effect, where we use the instruments, are different from the model where there are no instruments. So there was endogeneity in the simple fixed effect model. So this is one of the evidence that there was endogeneity. And next is we can also explain the fixed effect model where we use the lag of dependent variable can lead to biased inconsistent estimates due to endogeneity of the lag dependent variable. This issue raises because of the lag of dependent variable is likely to be correlated with an unobserved fixed effects. And this Nikel 1981 is a reference for that shows that there is a bias. So this is also shown in this file. So in this file, I'm going to give you a background. So first of all, we did a simple regression, and then we did fixed effect and random effect regression and compared the Hausman test. And then we go towards the calculation of instruments, and then use and we split the endogenous variable into an exogenous portion using the instruments, and then predict the y hat and use the y hat to estimate the model. And then what we did is that we checked if the problem is there. So Hausman IFE with FE. If the Hausman in above showing a random effect model, I would compare IRE with RE so that to check if there is endogeneity. Let's go back to the model. Now we go towards a model where the instrumental process is automatically done. So this is called IV-reg model, XTIV-reg, where dependent variable is employment rate, lag of employment rate endogenous variable, and it is instrumented using equal to sign lag 2 of employment rate and lag 3, and then the independent variables. So when I run this, it will do the similar model that we did manually, and then store the estimates, and then do the random effect model, store the estimates, and then compare which 2SLS model is better. So it is showing significant, which means fixed effect model is better. So I will compare the I2SLS FE with the FE, and it find out that it is significant, which is also confirming that there was endogeneity, which we have tried to sort it out. Next is that this XTIV-reg model is proposed by these references that I can show you in this Word file. So this 2SLS is proposed by Anderson and Shaw in 1981. This model can use the instrument to control the endogenous variable, and these are the scores that I have also shown you in the uh, codes. Okay, so we'll remove the no. So it has checked. So these were the references: Baltagi econometrics, Rudman, XTA Bond 2, and Nikel Bias paper. Next model is GMM model, which is developed by Arellano in 1987, which is XTIV Reg 2. So I will go back to the code file. So when I run the XTIV Reg 2, so dependent variable, 3 independent variables, endogenous variable, 2 instruments, fixed effect model, and small for small sample, and then also declaring that this is our endogenous variable. So when I run this, come back to Stata. So what has it shown? It has shown you several things. It has also firstly showed you the first part. First part was that we already did in Stata, that in this part where I estimated the the endogenous variable with instruments. This is called first stage. So when I have written first, it has shown me the first part where ln is equal to instruments and independent variables, from where it will estimate the estimated lag of endogenous variable. Then it has shown me that if the instruments are valid or not. So they are valid because they are significant. Then it's also shown you that if the variables are if it will show you if it is under-identified and weak identified, and it is so under-identified test, the null hypothesis is that it is under-identified. So it is significant, it means my instruments are good, they are not under-identified. Then are they weak or not? So H not is they are weakly identified. So my critical values is bigger than my test value is bigger than the critical values. It is showing that the instruments are not weakly identified, they are strongly identified. Okay, and then this is model for weak instrument robust inference. This test checks for null hypothesis that the instruments are valid or not. So there are three types of tests. All of them are saying that instruments are valid. Then this is the regression results. So under identification test, same which we seen above, weak identification test, over identification test. So there is another test that checks for over identification. So it should be insignificant, showing that they are not over identified. So there is no other problem. And then endogeneity test. It should also be insignificant, showing that the endogeneity has been sorted. So if I say at 1% it is insignificant, but you can try for other lags to try to make sure that these two are insignificant. I can store these estimates as IV to FE and then do the random effect model. Okay, so it is saying that it is either FE or FD. So we can check for it. There is no RE model here, so FD. So it's a first difference model. Here you can see. I will tell you what is the meaning of first difference model in the other model other models. Here what it did that it converts the variable into first differences. So you can see differences are here with each variable, and the model here are first differences. So here it is not unidentified, it is weakly identified, it is not over identified, and there is no endogeneity. So this way you can check for use this model, and then you can store this model as FD, and then you can estimate, and then you can compare these two models. Single name expected estimates are already stored. So Houseman IV to FE, IV to FD. So when you compare, it is saying that it cannot be compared, the variables are different, but we can compare it with the FE model to see if there was endogeneity or not. So it is different, so it is still saying that yes, the base model where there is no instruments are used, there is endogeneity. So I can come back to the Word file. So we have estimated this model, so I will change it here. It is FD, not RE, because there is no RE model in this. And then I will compare FE with FE only. What are the benefits as compared to IV Rank 2, which is GMM model, and IV Rank 1, which is panel to SLS? So the major difference is that I can see that the IV-Rec2 has more options to make it robust. There are more types of diagnostics available to assess if the instruments are good or not. It's more flexible to the ways to use the endogenous variable. Okay, and this reference is provided by Mark Schaffer, and then other variables are here. Other references are here. Then next is difference GMM, which is proposed by Arellano and Bond, 1991. This model is XTA bond, and the dependent and independent variables. Lag 1 means one lag of dependent variable is there, and then AR test to check for autocorrelation up till two lags. Two step means it will show you the first step, or do the first step where it will estimate the instruments with the endogenous variable, then store the estimates IV2. Now go back to Stata. I'll come here, so I will run this model. and you can see in this model that it has shown you do estimates. All of them are significant. There is one lag here. Overall, the wall test is significant. And now the difference with this model with previous one is, if you come back in this model, there were only how many instruments? It will show you two instruments because we have introduced two. But in this model, the difference of this model with the previous one is that that here from here on onwards, what they do is when you go in next observation, it adds on more lags. So here you can see there are 32 instruments, not two. So what does it do? Because when you estimate because you have two lags, and if you have one lag, so it means your maximum observation is so when you move from first observation to second, you have one instrument already available. When you go to the third, you have two instruments, lag 1 and lag 2. So on, you can add more lags. That's why there are 32 instruments. Okay, so how does it know? You can see it here, the lags from 2 to n. So how many n are there? So you can see the n is 7. So and then there are three standard instruments already there. So these are uh, this is the XTA bound model. Now we can store this estimates. Okay, and you can store it as IV2. So I will leave it as IV2 order so that I can differentiate with the others. Next is, now you need to check if there is endogeneity. So it is saying that Sargon test over identifying restrictions. So they are not over identified at 5%. Then there's command for a bond which checks for autocorrelation. Since we have already used one lag, so we can ignore the first lag for autocorrelation, even though it is still insignificant. We can ignore if it is significant, and we can check for the second one. So since second one is insignificant, we can assume that there is no autocorrelation. Next is a Hausman IV to FE to compare both models. So it is saying that the original model has endogeneity. Okay, now when we use this model is used when the time periods are small and number of individuals are more. So it is ideally used in this scenario. Next model is, we'll start with the word file again. Then there is difference GMM, which is XTA bond 2, and we have already discussed this. So this XTA bond is used when n is uh, large n and small t. Okay, so dependent variable, independent variables, controls, and log of lags. The GMM for endogenous variable, and collapse means that it will not add too many instruments, and these are independent variable at the level equation, two-step equation, and make it robust because these models are sensitive to heteroscedasticity. We'll come back to Stata and we'll run this model and minimize the word file. So you can see it here. When I run this, it will show you several things. First of all, the GMM model, wall test is here, and sample size stuff is here. Number of instruments are only 12. And then if you go down, it will check for autocorrelation. If there is no autocorrelation at second lag, it will show the over identification test, and it says that over identified. But if you have used the robust, you have to use the second one, which says that at 1% they are not over identified, but still there's a room for improvement in this model. And then there is a test for endogeneity. So there are several tests, and all of them, most of them are insignificant. At 1%, they are saying that there is no endogeneity. Okay, in the estimated model. So if it is significant, then you have to change the change the variables, or change the length of instruments so that you can check. For example, if I come back and in this command I copy it and remove the collapse function. You can see how many instruments are there, 39. So instruments have been increased, and there are slight differences that you can see it here. This model proposed by Arellano and Bond in 1991. Next model is system GMM. I will come from the word file. So system GMM is used when the persistent data where past values are strongly predict the future values. Means you need to do the add the lags. So XT2 N LN WKYS GMM LN collapse GMM LN lag 1 collapse equation level IV independent variables equation level two-step robust. So there is one more thing that is added in this model, that is this part. So we'll come back to this model. I will try to run this using by highlighting all of them. Okay, so no, this one we have to do this one and minimize the word file. And when you run it, so you can see that there are 13 instruments. Most of the variables are significant, and there is no autocorrelation, but the instruments are over identified, and there is endogeneity. Okay, so we use this model. Instruments are persistent, so it's model. This model is also called Blundell and Bond model 1998. Next model is extended GMM model. Here the difference is that we use the orthogonal function, which is extended GMM. So let's come back to the word file. So extended GMM complex data structures with both difference and system GMM can provide useful instruments. This provides help in achieving near better efficiency and and addressing potential biases. So when I run this model, you can see that most of the variables are significant. Instruments are 13. You can remove the collapse word to add more instruments, and then you can note that there is still some level of endogeneity left, and the instruments are over identified. So this model is used. So this model proposed by Rudman 2009. So this is the discussion of panel data GMM models. I'll come back to the word file again. So we started with simple regression and then talked about what will happen in the panel data. If there is a lag, I stored this model as an FE, so as a benchmark. Then talked about how instruments work to create a 2SLS equation, and I compared here. Then we talked about 2SLS model in a panel data directly, which is XTIV reg function proposed in 1981, and then compared with the FE model to confirm that there was endogeneity. Then the problem with this model and the above next model was that they will only keep those lags which we identify, like only two as your new ones and number of independent variables as the others. But the models that we discuss later on from here difference GMM, you have more instruments available rather than the instruments that we talked about. So these are some models that you can use. So at the end, I will give you another hint that if you are using panel data regression, but your model has endogeneity not because of the lag of independent variable, but because of other variable, then you can use the you should not use the extended or system or difference GMM or even simple difference GMM. Rather than you should use XTIVREG2 where you can add some other variable as an endogenous variable. Like I can write W here and add its lags or some other new variables as instruments. So that you can use your panel data model to address endogeneity, not because of the endogeneity present because of the lag of dependent, but because of some other variable theoretically. So I think this was sufficiently explained. If you have any queries, you can share in the comments, and you can read through the document because I have moved it slowly, so you can understand the concept. Thank you very much.